The serving time, T seconds, for a customer at an automatic banking machine is a uniformly distributed random variable with lower and upper limits 50 and 150. The mean serving time is 100 seconds and the standard deviation is 28.9 seconds. The serving times for different customers are independent. We want to sketch the graph of the distribution function for t. Well, it's going to be a rectangular distribution, and it's going to go from 50 to 150. So we know that it starts at 50, goes up to 150. The mean we know is at 100, and the width is 100, so that means the height here would be 1 over 100. So we probably should label axes. So this would be t for time, and this would be the function of time. The customer uses the banking machine. Determine the probability that the serving time is exactly 120 seconds. Well, straight away, because we know it's a continuous distribution, we can put 0 for that. The probability of any exact single value is always 0. Greater than 120, so 120 is here, and I wouldn't have added that to my little sketch if I'd actually been doing the test. I'd have drawn another little sketch down here. The width is 30, so we can see that's 30 over 100, or 0.3. What is the probability that exactly 3 of the next 5 customers will require at least 120 seconds to be served? Well, you could certainly do that as a binomial. In fact, that's a good way of doing it. And this sort of switcheroo between one distribution and another is very, very common in exams. So it's something that you need to get used to. But maybe let's not do it that way. So exactly 3, so that's going to be 0.3 times 0.3 times 0.3, but then the other two don't, so that's 0.7, 0.7. Then you just have to think about the fact that these 3 could actually occur anywhere. I've got them in positions 1, 2 and 3, so you're just going to have a 5 choose 3 at the end, and so that is 0.3 cubed multiplied by 0.7 squared, and then we find those in advance, don't we? So it's NCR 5, 3, and execute, and that's 0.1323. It is decided to record the serving times in minutes instead of seconds. Determine the expected serving time. Well, we know it's 100 seconds, so that's 1 minute 40 seconds, which is 1 2/3 minutes. Now, variance we know is standard deviation squared, but it's easier to change the standard deviation first because standard deviation is in the same units as the actual values. So in other words, the standard deviation is in seconds at the moment, and we know that that is 28.9 seconds. So 28.9, change that to minutes, is 60, and then to get variance we'll just square. So that is going to be, so let's use a bracket, so that is going to be 28.9 divided by 60, and then we're going to square that. So that'll give us 0.2320.